Hello all, welcome to the module. So today we will see how to use the online version of NA Multisim. So Professor Hardik has already discussed about the circuit in the last module, especially for acquisition of EEG signals from the human. So in order to understand the working of the circuit, it is better to do a circuit simulation so that we will understand and we can also analyze the design performed on the circuit is as per the requirement or not. So one particular way of understanding is either by building it on a breadboard. First we will always go with a theoretical design, and based upon the theoretical design, after optimizing it, we will go with hardware. But prior to the hardware, if you use a simulation, it will always be helpful in order to rectify the designs within lesser time. So in this I will show you how can we use an online simulation software, which is a circuit builder software. How can we make use of that circuit simulation software in order to analyze different circuits. So the complete circuit I will be dividing into different subsystems. Each subsystem I will be looking about its requirement and whether it is matching our requirement or not. So in order to understand, in order to build, first we have to get flexible, first we have to get used to the features of online multisim. So in this module I will try to get used to the online multisim. In order to work with this circuit simulation software, online circuit simulation software, you just go to multisim.com. So I have already opened the page multisim.com. So in case if you don't have an account, just create using sign up. If the account is already existing, just log in using your existing credentials. So right now I have already logged into my account, so you can have a look here, my account details of my account. So now in order to create a circuit, on the top right on the top right side you can see a green color tab which indicates a create circuit. So just to create this circuit, just click on this create circuit button. It initializes the interface for circuit building. This is the interface for circuit building. So where you can see different options available. So on the top we can see the options, something like schematic, grapher, split. The idea of the schematic is to build the circuit for analyzing it. So whatever the circuit we planned to understand, what we plan to analyze, that can be built in this particular tab. So during this tab we can see a page, a white color page, where all the blocks required has to be dragged in place at this point and do the connections. That means we are, whatever the design we trying to understand or analyze, we will be putting on this graph. Whereas there is another tab called grapher. The idea of this grapher is to visualize the output waveforms at the selected point. So which is nothing but, in case if we want to provide a function generator to the system, to the circuit, at the same time to analyze an output. So all the responses from the function generator, the responses from the circuit will be looked or will be visualized. The output waveforms from each of these things will be visualized using this particular tab. So this particular tab is only meant for visualization purposes, provided we should have to mention at which point of the circuit the visualization needs to be plotted. We also have another menu here called split, where you can see both schematic as well as grapher windows side by side. So however, in this case we were not able to see anything here because we have not built any circuit at present. At the same time we are not executing or we are not running the software. So that is why it always shows waiting for the data. So these are the major and main basic functions which we will be always using it in order to build it. So, in our practical applications, when we are designing a filters or when we are understanding the functionality, we may opt for different simulation, we may perform different simulations or different analysis on the circuit. So, those analysis we can further verify at this point. We have 4 different analysis available: interactive, transient, AC sweep, DC operating point, right. On the left hand side, it contains all the circuit components required to build it. So, for example, if we want to understand the voltage at one particular point and the same has to be visualized, we may have to go with a voltage probe. This is something looks like a voltage probe. So, which will be available in analysis and annotation toolboxes. So, voltage, current, in case if you want to see what is the current flowing through that particular wire or a cable, can be visualized using this. So, digital voltage and digital current probes both together we can verify it, and this act as when we are considering voltage reference instead of ground, some other voltage reference, we can put this particular probe as one of the reference, another probe where we are measuring it. So, it measures the voltage with respect to this reference rather than with respect to the ground. If this reference does not exist, the whatever the voltage it measures is with respect to the common ground. So, these are the different ground different schematic connectors, like a ground, common reference point, a connector and a junction, if you want to have a multiple connections at one single point, which is nothing but a junction. Similarly, on the third pellet you can see different sources starting from AC voltage, AC current, clock voltage, clock current triangular wave, DC voltage. So, irrespective of if you want to perform any analysis using AC, you can see any clock related you can apply, any triangular voltages, DC voltage, everything is available at this particular toolbox or pellet. So, most of our electronic circuits uses a passive elements like inductor, capacitor and resistor, especially pots too. So, all different passive elements are available at one particular tab, passive tab, where you can see all resistors, capacitors, everything. On the next tab we can see different operational amplifiers. So, these are all generic operational amplifiers, 3 terminal op amp, 5 terminal op amp, ideal comparator, and these are the existing operational amplifiers in the market, 555 op amps. The features or the specifications of these op amps when you select will be closely matched with respect to the specifications available, specifications given in the data sheet. At the same time, with these op amps we can also change the specifications, default specifications provided in order to make use of similar to the existing component available in the market. Similarly, we have a diodes, different diodes, rectifying diodes, Ginnar diodes, LEDs and general purpose diodes which are commercially available, and transistors, P channel, N channel, NPN, PNP, MOSFETs, everything, indicators, switches, analog blocks, digital analog blocks we have already seen here, and we also have a digital blocks too. So, this particular I hope these things whatever we have seen or anything working with simulation packages or similar builder softwares, it's basically completely like intuitive. You will always have all the dedicated blocks available in the database. You may have to pick and drag and drop onto the circuit builder part, and you have to connect a circuit accordingly. So, once the circuit is done, we can simply press a button here, run simulation button. So, in order to visualize the outputs or in order to visualize the input and output waveforms. So, in order to make you clear, I will just show you an example of using this particular Multisim software and analyzing using that. So, I will name it as test circuit, sorry, I will try to build an inverting amplifier. So, either you can go with 3 op amp based inverting amplifier or 5 terminal op amp based. The only difference between 3 terminal and 5 terminal is, in case of 5 terminal, it contains external other 2 terminals apart from 2 input and 1 output terminal. Those are plus VCC and minus VCC. Whereas in case of 3 terminal op amps, the plus VCC and minus VCC is fixed in the specification. It does not mean that it cannot be changed, it can also be varied in the settings parameter. However, the default will be 12 volts, whereas in case of 5 terminal mode, it has to be provided using voltage sources. I will show you the difference between those two. So, I will consider 3 terminal, at the same time I will also consider the 5 terminal. So, these two are, one is non-inverting input terminal, inverting input terminal, similar to what you have seen in the U2, which is a 5 terminal op amp, and this is an output terminal. So, the only difference between these two is that you have extra 2 terminals to provide plus VCC as well as minus VCC. So, this has to be provided using external voltage sources, but whereas in this case, when we click into the on to the configuration pane, which is located on the left side of the top left side, and you click here we can see the virtual modal parameters, which has been a default parameter. So, in order to map with respect to the existing operational amplifier, you can change these model parameters to act according to the commercial operational amplifiers. Similarly, there are 2 more terminals or properties available. So, which is nothing but VOMP, VOMN, which represents the positive voltage swing and negative voltage swing. So, the default positive and negative voltage swing is 12 and minus 12. In case if you want to replace, you can change to 12 and 15 to minus 15. So, as you are already aware, when the operational amplifiers are working in amplification mode, in a negative feedback mode, the maximum output voltage it can provide, irrespective of whether it is inverting amplifier mode, non-inverting amplifier mode or a comparator mode, the output of this operation amplifier will be equal to or lesser than the plus VCC and minus VCC. So, that reaches to the saturation as long as the output goes close to the plus VCC and minus VCC. So, the plus VCC and minus VCC is very much important when in order to design the circuit or to decide the saturation voltages. Now, in case if you want to further understand about the building of simulation software or understanding about NM Multisim, you can further look into the internet. Multisim tutorials are also available, where you can understand each and every property which has been mentioned in this particular Multisim. You can go to multisim.com and there exist a few tutorials, you can have a look. Now, I will show you how to build it. So, when you click on that, you can see 4 options available. This option is used for flipping or mirroring of the operational amplifier, you can see that. So, in the previous case, if you observe, the positives on the top and the negatives on the bottom, but it is always easy, or it is our we have come across different circuits where negative terminal will be on the top and positive terminal will be bottom. So, you can easy to recognize the inverting amplifier configuration as well as non-inverting amplifier configuration. So, that is why in order to have that, I will mirror it, I will rotate it, so that the negative is on top and the positive will be on the bottom. Similarly, the same thing you can do. Of course, it can also be done at this point too. So, go to the symbol, just go to the other particular part, that is all, it will automatically swap accordingly. So, the second option which is available on the top right side of the U1 is a delete button, in case if you do not want to use it. This is a duplicate button, where you can duplicate the same circuit, same component, and this is a rotate, which you have already seen. So, in this case we may not have to provide with external power supplies in case of U1, whereas U2 we have to provide with external power supplies. So, now in order to construct inverting and non-inverting amplifier configuration, I will use U1 as an inverting amplifier configuration and U2 as a non-inverting amplifier configuration. So, to do that, so we require a passive elements as well as power supply units. So, what I will do, I will take a passive elements. So, in order to once you take the passive elements, okay. So, R1 being the feedback, R2 being the input resistor and R3 being the feedback in case of U2 and R4 being the input resistor, I am considering it. So, in order to make the connections between the resistor and to the operational amplifiers, when you place the cursor, at present is it is in the hand tool, when you place a cursor close to the edge of any terminal or edge of this particular component, it will automatically change to a wiring tool. Just click on at that part and again click, right. So, similarly here I am doing it. So, wherever the junction is forming, wherever the connection is forming, we can clearly observe a circle, a zooming out circle. So, which indicates that at this particular point you can make a connection. Once you click on it, just left clicking it, it will automatically make a junction. Similarly, even on the other side, the same way I am even doing at U2 part. But in this case we may have to provide positive VCC and negative VCC. So, we require ground terminals as well as positive and negative. In order to make the ground terminals, in the second tab, in the second toolbox we can see the ground. So, since it is an inverting amplifier configuration, so the positive terminal has to be connected with the ground and I am duplicating it, connecting at this point. Sorry, this is a non-inverting amplifier configuration. So, this terminal will be connected at this point. So, we also have to apply positive and negative. I will go to the third tab, sources, where it contains all different types of sources. I will go to DC voltage, I can connect at this point. I am duplicating the ground and then connecting it. So, now if I want to change any resistance values or something, just click on the number or just click on to R2, you can go to the settings pane, configuration pane. Here we can see the resistance, either we can change at this point or during the simulation instantaneously we can vary too. So, in this case I am going with 1K. And whereas this one I am changing it to 10K, so the gain is 10. So, since op amp is powered with plus or minus 15, the maximum voltage that you can see is close to 14.3 something. You can refer the data sheet, it depends upon the op amp that you are considering, but it will, the saturation voltage will be close to lesser than 15 volts, lesser than plus or minus 15. So, if I apply 12, since the gain is 10, the output will be 120 volts theoretically, ideally, but because of the positive and negative voltages it cannot go more than plus or minus VCC. So, as a result I am changing it to 1 volt. So, since it is a negative amplifier, we know that theoretically the output voltage should be minus 10. We will verify that. So, in order to verify, what I will do, I will put a voltage probe at the output terminal. Similarly, so instead of voltage I will go with simple an AC signal. So, whereas in case of 5 terminal we may externally have to connect the voltage sources. So, this I am going with a 12 and I need to take one more voltage source for the negative terminal connection. I am rotating it and then connecting it to the negative terminal with same ground. Whereas input I will go with AC voltage connecting with the same input terminal even here too. In this case the gain is 1 plus 1 2. So, since it is a non-inverting amplifier configuration, whereas in this case it is 10. So, the ground so in order to visualize the input, output and everything, So, green color represents the input, green color represents the input, blue color PR2 represents output, whereas PR3 dark blue, sky blue and dark blue represents the output from the non-inverting amplifier configuration. So, right now I am going with interactive mode, just click on this. Whenever we go to the grapher, we can see. So, as we know that PR1 is input, so the green color represents the input, which is 1 volt, and PR2 is the output from the inverting amplifier configuration with a gain of 10. So, since the input is 1, the output is of 10, and since it is in inverting configuration, inverting amplifier configuration, there will be a phase shift of 180 degree. As a result, whenever it is a positive, we are getting a negative output voltage. Whereas PR3 is output from non-inverting amplifier, we can have a look onto the PR3, which is of dark blue, where the phase is almost same, equal to the phase of it is same as input phase, but the gain, since the gain is 2, so the amplitude is somewhere around close to is 2 volts. So, this way we can understand the analysis of any circuit using circuit simulation software. Now, we will see the actual circuit which we would like to analyze, which Professor Hardik would have already discussed in the last class. So, this is a signal conditioning circuit. So, in the first stage we have input stage amplifier, where instrumentation amplifier. So, now I will show you how to construct this instrumentation amplifier, as we already discussed the use of instrumentation amplifier at this point and the use of INA 116, and since we do not have the commercial, we do not have the exact 116 in circuit simulation software, as well as we do not have INA instrumentation amplifier configuration itself in the online database. We can in order to understand the functionality of instrumentation amplifier, we can construct an instrumentation amplifier itself using a normal operational amplifier. So, most of these instrumentation amplifiers are 3 terminal based instrumentation amplifier, 3 op amp based instrumentation amplifier, where the first op amp, the second op amp is used for the gain application to provide the gain to the instrumentation amplifier, whereas the third op amp which measures the difference between both the outputs. So, let me draw the instrumentation amplifier, 3 terminal instrumentation amplifier configuration. So, this is one input. So, I can say it as IN plus, and whereas this is another input IN minus. As most of the people know the configuration of instrumentation amplifier, I am not discussing much about this, but I will draw the circuit and I will try to construct the same in order to visualize the functionality as same as not. So, the negative terminal will be connecting at this point, this negative terminal also I am connecting at this point, this constitutes as a gain, whereas a third operational amplifier is used as a differential amplifier. Okay, I will draw it properly. 1, 2, a resistor in between, this is minus, this is plus, this is IN minus, this is IN plus. So, the negative terminal, since we always require a negative feedback, so this will be connected at this point, whereas this will be connected at this point, this act as gain, whereas it contains another operational amplifiers in differential amplifier configuration with a gain of 1. So, this is a 3 terminal operational instrumentation amplifier configuration. So, since these gains are almost are same, the gain of this the third operational amplifier, which is in a differential amplifier configuration, is 1. So, this is the output. So, in order to understand the relation between input and output, we can have a look. So, I am dividing this as VO1 and I am saying this as VO2. So, we know that V out is nothing but since the gain is 1, in this case VO1 minus VO2. So, if you can find a relation between VO1, VO2 and IN plus and IN minus, the complete operational amplifier instrumentation amplifier gain we can understand it, or we can derive the relation between input and output terminals too. So, in order to understand, first if you observe this particular point, as we already know, what are the input, we applied the positive terminal, the same input at this point as well as at this point. So, as a result, this terminal is nothing but IN plus and this terminal is IN minus. So, the current flowing through this, I will take a new page so that it will be easy to further discuss on this. I will construct in a 3 terminal operational amplifier, since we do not have INA 116 in the online database of NA Multisim. So, even it does not have an operational instrumentation amplifier configuration, a 3 op amp based instrumentation amplifier I will show. So, it contains 3 op amps minus plus. So, these 2 op amps are used to provide a gain to the operational amplifier, whereas the third op amp will be in differential amplifier configuration with a gain of 1. So, plus minus I am considering. So, this is a differential amplifier configuration. So, where this terminal is also grounded. So, since the gain is 1, all the resistors should be the same. So, differential amplifier configuration should be in inverting amplifier configuration. This is R and this is R. This is V naught. So, we need to derive a relationship between V naught and IN plus and IN minus. So, if I consider the output of this op amp as VO1 and the output of this op amp is VO2, and since we will be connecting VO1 at this point and VO2 at this point, so we need to find out a relationship between, and we know that the relation between V naught and V1 VO2. So, V naught is equal to gain is 1 in this case, VO1 minus VO2. If we once find the relation between V1, VO2 and IN plus and IN1, our problem is solved. But however, this is not a complete circuit, still I have to build a complete circuit here. This negative terminal will be connected at this point, this negative terminal will be connected at this point, this RA I can consider, and this is nothing but RG. So, this RG is responsible to have a gain that is required for the instrumentation amplifier, right. Since both the terminals IN plus and IN minus, or the input voltages are being connected at positive terminals of operational amplifier, the input impedance will be very higher, right. So, once we derive a relationship between V1, VO2 and IN plus and IN minus, it will be very easy. So, as we know the property of any op amp in a negative feedback configuration, virtual short. So, whatever the terminal, whatever the voltage at positive terminal, the same voltage will be at the negative terminal too. So, this is IN minus and this is IN plus at this terminal. So, as a result, so the current flowing through IRG is nothing but right. So, this is the current flowing through, but if you observe the input terminal at since this is directly connected to the negative terminal, even this is directly connected to the op amp terminal, there won't be ideally speaking there won't be any current flow through these terminals. As a result, whatever the current flowing through here IRG is same as the current flow even in IRA. So, now we can say VO1 minus IN plus divided by RA is equal to IN plus minus IN minus divided by RG is equal to IN minus minus VO2 by RA. So, in order to get a relationship, first I will consider these two, then I will consider these two to solve it. So, when I try to solve it, so since we know since we need to get a relationship between V naught and In plus and In plus and In minus, first I will try to eliminate VO1, I will get a relation between VO1 and In plus and In minus, and I will get later on I will get a relation between VO2 and these two input terminals. So, when we see this, VO1 is nothing but RA by RG into In plus minus In minus plus In plus. So, when I take In plus as a common, I can consider it as RA by RG plus 1, and similarly In minus of In minus into RA by RG. So, similarly in other case, if I consider these two, so minus VO2 I will say RA by RG into In plus minus In minus plus In minus. So, when I take VO2, this is nothing but, okay, let it be minus VO2. So, I will take In plus as common. So, now I will get, so in this case I have to take In minus as a common, because I have two In minus. So, if I take In minus as a common, I will get RA by RG minus. So, what I will do, I will take minus of okay, I will take minus VO2 is equal to minus of In minus. So, which is nothing but RA by RG minus 1 plus In plus into RA by RG. So, now we got a relation between V1 and VO2. Now, if I want to subtract V1 and VO2, what I can get? I will take RA by okay, I will take In plus between these two. So, here it will be RA by RG plus 1 from here, and in this case it is nothing but plus RA by RG, and I will take again here In minus as a common, again I will take In minus as common. When I take In minus as a common, from here it is minus RA by RG, and this will become minus RA by RG plus 1 So, when I see this, rewriting this one, I can write it down as VO1 minus VO2 is equal to RA by RG, 2 RA by RG plus 1. If I take a common, this is nothing but In plus minus In minus. So, we know that VO1 minus VO2 is nothing but V naught. So, we get 2 RA by RG plus 1 into In plus minus In minus. So, right. So, if you fix RA as particular constant, so the gain of this op amp entirely depends upon RG. So, that is how it works. Now, we will see how to construct this and how to analyze the instrumentation amplifier configuration using multisim. So, what I will do, I'll okay, go to the schematic. Now we have to use a 3 op amp based instrumentation amplifier since we do not have. So here I'll make it as instrumentation amplifier. So I'll delete the previous circuit. I need 3 op amps in this configuration. I'll take a 3 op amp base itself, 1, 2, but whereas this one I have to flip. Two way of flipping it, either we can go to the settings and directly use it, configuration pair, or we can use a duplicate method, we can use a mirroring and rotation method. And we also need a passive components. I'll rotate it. So I am taking RA as 1K, RA as 1K. Similarly, this is also RA. Since the same name is not possible to create, I am saying it as RA1, and whereas RAG, I'll take a potentiometer. Here I'll connect. The negative terminal has to be connected at this point, whereas this negative terminal has to be connected at this point. So the first configuration is done. This is, I'll name it as RG. So this is IN plus and IN minus. So I'll take 2 voltage sources to verify it. I'll take a DC voltage, one more DC voltage at this point, whereas other terminal has to be connected with a ground. Okay. So whereas this particular configuration we have to use a differential amplifier. So I require a few more resistors. I'll take this resistor. The output of the first op amp has to be connected with it. So I made the complete circuit here. So the gain of this op amp is 1 now in this difference amplifier is 1, whereas the gain of this is nothing but 1 plus 2 RA by RG. So since it is 50%, this is 5K. So RA is 1. So 2 into 1 by 5, 1 plus 2 by 5. So the value of 1 plus 2 by 5 1.4. So since so the output voltage will be the difference between these two into 1.4. So if I set the V1 as 1, V2 as 2, then I should get so the positive terminal IN plus is having a lower voltage when compared to IN minus. So this will be minus 1 into 1.4, which is nothing but minus 1 into 1.4 into minus 1, which is 1.4. So now I'll connect a voltage probes at this point to visualize it. Since it is not an analog, we may not have to go into the grapher view. Even if you look into the grapher view, it will be like a constant DC. So we get 1.4 when we have simulated it. So it's a completely DC. 1.4. So in the real time we can also further change the values of V1, V2. So V1, let us say 2 volts, I will change it to 3 volts, this will be positive 1.4, this let me make it as 5, 5 minus 3, 2, 2 into 1.5, 2.8, this I will change it to somewhere around 7, positive 2.8, this I will change it as 10, 4.19, this also I will change it to 13, so 13 minus 10, 3 into 1.4, 4.2, we are already at saturation. So 9 minus 0, 9 into 1.4, the value is of 12.6. Since the plus or minus VCS is 12 volts, it can only show the maximum 12 volts at this point. If I further increase the saturation voltages, or by changing the op amp positive and input voltages, positive plus VCC and minus VCC, we can see the change to 12.6, right. So this is how we can understand about this is how we can analyze any kind of a circuit using circuit simulation software, provided the database relevant to the component that we have selected in the in the circuit is available. However, these are the some of the generic op amp configurations which will be inside the 3 terminal, which will be inside any instrumentation amplifier, right. So now when we come back to our slide, so we finished about the input stage amplifier configuration, the working of instrumentation amplifier. We have also finished about, we have also seen about a broadband amplifier and final pass amplifier, and since we know about the gain controller part, so the idea of this gain controller is to act as attenuator, where it has been provided with SPST switches, 2 SPST switches and R7 and VR1. VR1 and VR2 are the pots, 100K pots, and R8 is 19 kilo ohms resistance, R8 and R7. So the idea is that whenever the switch is closed, that means whatever the output voltage at this point will be directly connected to this terminal, because current will always flow through the short circuit path. So low impedance path, which is short circuit path at this point. As a result, the attenuation factor will be smaller when compared to as a result the attenuation will be based upon the VR1. Even similarly in this case, it depends upon the VR2. Whenever the switch is open, again when the switch is open, this 910 kilo ohms will become in series with the pot. So now it will become something like this. This will be 910 kilo, and whereas this is the pot. So if I say we are the pot value is of 50K, now the output will be 50K into Vin divided by 50K plus 910K. Right, the factor of attenuation will automatically change according to the selection of the switches and according to the VR1 and VR2 pots. Of course, it is not only the way that the gain setting has to be done. We can also further use another operation amplifier in order to have a different gain settings by changing the pot potential pot itself. So the idea of having a different stages is to filter out different signals and to collect only particular frequency range of signals at the output side. At the same time, each stage will have its own gain. As a result, the total gain of this particular circuit will be the gain of this stage, gain of this stage, the gain at this stage, and gain at this stage. The multiplication of all the gains will be the total gain of the circuit. So when we look into the gains of each stages, when we consider input stage based upon the design, based upon the resistance value that we have selected, the targeted input stage amplifier is of 19.5, the targeted broadband amplifier stage is of 93.5, and the attenuator third stage which acts as an attenuator in this case is of factor of 9, and the final band pass filter is of 58.8. So when you multiply all the factors, so 19.5 into 93.5 into 58.8 divided by 9 is the total gain of the operational of the stage. So the value of this is somewhere around 1 lakh. 93.5 into 58.8 divided by 9. $19.5, 93.5 into 58. Oh, sorry. 19.5, 93.5 into 58.8 divided by 9. So if we don't consider the attenuator factor, the gain of this stage is 1,07,264 without this. Divided by 9. So this attenuation factor will decrease the gain of the overall circuit. So this is the idea of this is the analysis that we can understand from the circuit that we have used for acquiring EEG signal and conditioning the EEG signal. Thank you.